In this video, we provide a brief introduction to the pipe operator. Tidyverse data science relies heavily on the so-called pipe operator, which looks like percent greater than percent. It's a bit awkward the first time you use it, but you get the hang of it as you do it a little bit more. The operator is really designed to provide a more readable coding style. Again, the idea here is that we're able to look at our code and immediately see what is being done at each stage. It's very easy to read and it's cognitively clear. This is made easier by the fact that it allows code to be expressed from left to right and top to bottom in the same way that we read English. Now, since the code sequence is a little strange, RStudio actually provides a hotkey sequence that makes this a little bit easier. If you're on a Windows machine, you can push Shift-Control-M, and that will actually type out that pipe operator for you with spaces on both sides so that it looks nice and neat. If you're on a Mac, you can push Shift-Command-M, and it will do the same thing. Now, the pipe that we're going to be dealing with is called the forward pipe, and this is by far the most common one. The basic idea is that it allows you to write function calls that look like this instead like this, which looks really strange at first, but as you do it more, you get the hang of it. So for example, let's say that we have a function f of x equals 2 times x. The usual way that we would call this function is just to type f of 3. So f open parentheses 3 close parentheses, and of course we get 6. If we were to use the pipe operator, we would type this like this. And in fact, this works as well, although I will always encourage you, when you pipe, to use the parentheses. Now at this stage, we can't really see much reason why you would want to do this. It just seems to make things more complicated. One of the reasons why we do this is when we want to apply functions iteratively, or we want to apply functions several times. So for example, let's say that we want to apply f twice to 3. Piping, it would look something like this. So 3 piped into f piped into f. Whereas if we wanted to call it in the usual way, it would look like f open parentheses 3 close close, which is a little bit awkward. And since we're going to do this kind of function application a lot in the Tidyverse, it really is nice to have a nice consistent syntax with which to specify those operations. Moreover, the operations usually run across lines. So you'll see something like this: 3 piped into new line f piped into new line f. And the way we would usually read this is take 3 and apply f to it, and then apply f to that. So 3 times 2, which is 6, times 2, which is 12. What the pipe is actually doing is allowing us to input the return value of the left-hand side into the first formal argument of the right-hand side. So for example, let's say that we have a function that takes in 2 different arguments, x and y, and simply concatenates them together. If I say f of 2, it assumes that that 2 is this x right here. Of course, it gets input right there, and the return value is 2, 1. Now, if I say 2 piped into f, that's of course exactly the same thing. So there's no difference in the return value. The point here is that whatever is on the left-hand side, here, that 2 is always going to be piped in for the first argument of the function. Of course, the pipe is sufficiently flexible to pipe into other arguments also. For example, if I wanted the 2 to go in for y, I would just use the dot, as we see right there, and the 2 goes wherever the dot is. That's how the pipe works. Since in this function the x is defaulted to 1, I could simply say 2 piped into f where y equals dot. So that means f of 1, 2, and the return value of course is 1, 2. The pipe will also allow me to pipe into 2 different places at once. I just use the dot 2 different times. So whenever you use the pipe, wherever you put the dot, that's where the left-hand side is going to go, and if you don't use a dot at all, it's going to go as the first argument of the function. Now, in the Tidyverse, piping is almost always used with data. So the left-hand side is almost always starting with data, and then usually you do something to the data to manipulate it in some way, and then maybe you do something else to it, and ultimately you plot it. Or ultimately you model it. Something like that. Those are very, very common applications. Notice that they don't ever overwrite data itself. For example, after I run either this or this, the data has been manipulated, but it has not been saved as data again. It's a very convenient thing to do if your computation time is very, very small and you don't actually want to overwrite your data set. So that's the major use case of piping in the Tidyverse.